Okay, this is number 4 for page 4 work, okay? This is very difficult. All right, always start with the given bit of information and the given number value, okay, that you are given. So it's 75.0 grams of O2. If you have that amount, we're going to need to calculate the mass of CO2 that will be formed. So I'm going to put equals. I'm going to put mass, by the way, is what we want of CO2. That's measured in grams. So we're going to put grams of CO2. I'm going to leave a blank space for the final numeric answer and also a big blank space for the calculations I'm about to do or the conversions I need to do. Okay? Okay, so we have grams of O2. And we need to know, and what we would like to know first before we do the huge calculations, how are these two related? These two are related with this chemical formula. This is telling us the relationship. And everything that you see is in moles, meaning this. How you're supposed to read this is for every 2 moles of this C4H10 chemical or molecule, 2 moles of that, of this, okay? When you add that to 13 moles of O2 chemical, 13 moles of this O2 chemical, if you add 2 moles of this C4H10 chemical and 13 moles of this O2 chemical, you will create 8 moles of CO2 chemical and 10 moles of this H2O chemical or molecule. Okay? Okay. So what the focus though is on how oxygen is related to CO2 because those are the 2 bits of information we're given. O2, and also we need to find CO2. So don't worry about the other guys. So the relationship numerically is for every 13 moles of O2, you can create 8 moles of CO2. Think of this as a logic puzzle. If you had, let's say, 26 moles of O2, which is twice the amount in this kind of ingredient or recipe or chemical ratio, if we had 26 moles of O2, how many moles of CO2 you would make? Well, you would make, just like here, 13, 26 is twice the amount, you just twice the amount of this, 8 moles of CO2. So it would create 16 moles of CO2. Hopefully you could follow what I just said, okay? And I take it that this isn't the first problem you've already watched a video for on this worksheet. If it is, I would recommend that you go back and practice the other problems first before watching this video and trying this problem. Okay, so my thing is, we would like to know how many moles of O2 we have. We don't have that yet. We have grams of O2. We need to convert this into how many moles of O2 we actually have. So we need what's called the molar mass of O2, okay? We need to know how many, we need to know how many grams of, how many grams is 1 mole of O2 equal to. Okay, so we're given the molar mass of CO2. Unfortunately, that's not what we want. We want just O2. So what we need is a periodic table. Take a look in this video up here. I have a tab open for what's called periodic table. It's called ptable.com. That's a great way. That's a great thing. All right, that's a great resource, I meant. Okay. The chemical formula is O2. On the periodic table, let's look at O for oxygen. There we are, oxygen. Look at the big number. That is the molar mass of oxygen. 1 mole of just oxygen, not O2, of just oxygen weighs, let's approximate that to about 16. I'm going to write that on a separate sheet of paper, and I'm sorry, these problems will require you to do that. So oxygen, 1 mole weighs 16 grams, but the chemical formula we're looking at is O2. So what do you think you're going to have to do to that number to get the molar mass of O2? Just multiply it by what it says, 2. Okay, what you just solved for was the molar mass of O2. What that means is for every 1 mole of O2, that would weigh 32 grams, and we'll say of O2. Okay, we're going to take that value and multiply it to this, to go from grams of O2 to convert it to moles of O2. The thing is, you have two different choices. You could either multiply this by this form of the ratio or this form, where instead of mole of O2 on the bottom in the denominator of this ratio or fraction, it's going to go on the top. 1 mole of O2 and 32 grams of O2 will now be on the bottom. The question is, I have to choose between this or this form to multiply to this. Which of these two forms will I pick? I'm going to pick this one. And no, that is not by random chance. That is the form you will need to multiply it by. Let's copy that down and I'll explain why. Okay, why? Because when I multiply it in this order, this ensures that the grams of O2 will cancel out. Because 75.0 grams of O2 is written as a whole number or a big top number, and when you multiply by a fraction where that same unit occurs again only in the denominator, they will cancel out. And I don't want my final answer to have grams of O2 at the bottom as as a unit. I want this unit. I'm not there yet, but I'm getting there. Right now, if I did this calculation, 75 times 1 divided by 32, I would find out how many moles of O2 I have, okay? And by the way, the reason why this cancels out is the same way that something like this, 12 times 3 divided by 12. The 12s would actually cancel out algebraically. Why? Because if I did multiply this out, that would be 12 times 3 divided by 12. Only when you're multiplying, by the way. The 12s would actually cancel out. Well, I'm just going to focus on the way it cancels out looking like this first. That logic applies to units, such as what I have over here, okay? Okay, so if I multiply this out right now, let's just do that, just out of curiosity. 75 times 1 divided by 32. I could put that in one entry in the calculator. I have 2.3 moles of O2. Let's just keep that in my head without having to write equals 2.3 moles of O2. So think about it. If 13 moles of O2 gives me 8 moles of CO2, and I know 13 to 8, how many would 2.3 moles of O2 give me? I don't know. I think it's best just to leave it to some multiplying and dividing. Okay, so what you're going to do is you're going to multiply it to that conversion factor. What was that conversion factor ratio? Every 13 moles, sorry, should have put moles of O2, you can create 8 moles of CO2. Sorry, I wrote that up here. I want to multiply this by this, or the other alternate version. 13 moles of O2 will go on the bottom, and 8 moles of CO2 will go on the top. Okay, which fraction or version am I going to use? This one or this one? I want to choose the one where when I put it in here, the mole of O2 or that unit will cancel out and I get a new unit. It's this version right here. So this is the preferred version. So on the top will be 8 moles of CO2 and 13 moles of just O2 will be on the bottom. Why? Because when I multiply the 1 mole of O2 times this fraction, the unit mole of O2 is here, and it occurs on the bottom of the denominator here. That will allow me to, cross off or eliminate or cancel out the mole of O2. If I stopped right now, I multiplied these numbers, and I divided it by 32 and 13, I would get how many moles of CO2 I have. But that's not enough. I want to know how much that's going to weigh in grams, okay? So, like I said, I don't know what this is if I computed this. Let's say it's 3 moles of CO2. I need to know how much that would weigh in grams. So what do I need now to multiply next? I need what's called the molar mass of CO2. Normally, I would have to calculate it with this periodic table and look at the carbon and add it to the oxygen. Well, guess what? Out of a matter of convenience, it was given to you by me. I'm the one that wrote this worksheet up, okay? So I gave you a little bit of a break. Okay, so let me clean up the worksheet just a little bit before I tell you what to do next. But you will use this molar mass of CO2, which is 44. The way you should read this is 44.01 grams. That's how much 1 mole of CO2 weighs. Sorry, I'm just going to do a little bit more erasing, so when I show you more stuff, it'll be on a cleaner paper. Okay, let's move this over here, the camera. Okay, whoops. And by the way, that's 44.0 grams of CO2. I want to multiply this to this, or the alternate version of this molar mass, which could be reported as 1 mole of CO2 over 44.01 grams of CO2. Now which version do you think it is? Okay, it's actually going to be this version right here. So let's multiply that to 1 mole of CO2 on the bottom and 44.01 grams of CO2 on the top. Hopefully by now you understand why I chose this, not this. This is not the version I want. I want this version. The reason why is because this last value that I had from the last calculation is in moles of CO2. I want that to cancel out. By multiplying it by this version, where the moles of CO2 is on the bottom, this multiplied to this fraction with the same unit on the bottom, the unit here and here will cancel out, leaving me, if I did the calculation with all the numbers that I have, like that 75 and this and this and this and this, the last unit that is left over will be grams of CO2, which is what I set up to want, because that's what I wanted. I wanted the mass of CO2, okay? Okay, so the last thing that you're going to have to do is just put this all in a calculator now. You're going to have 75 times 1 times 8 times 44.01. All the numbers on the tops of the fractions or conversion factors or ratios. 75.0 technically times 1, the number on the top, times that by 8, times that by 44.01. Whatever answer I get, I'm going to have to also divide it by the numbers on the bottom. 32 divided by, and divide that by 13, divide that by 1. Let's just put everything all in one entry on the calculator. Okay, continuing off from what I just said, let's divide this by 32. Divided by 32. Okay, that's not the only number we have to divide by. We also have to divide by 13. So on your calculator, just put divided by 13. We got one more number to technically divide by. It's just 1, but it's right here. 1. So let's put the divided by sign in the calculator once again. Put 1. That is the final answer. 63.47. We'll round this to about 63.5. Uh-oh. I think I made a mistake, by the way. Okay. Oh, no. This answer is fine, but I just realized on a little key here, I made a mistake, and I'll have to fix that. You won't see it. Don't worry. I was just talking to myself. Okay. Well, that's the final answer. Let me see. Did I do everything right? 60 to 75 times. Yeah. Okay. Just making sure. Yeah, everything I did was correct. Okay. All right.